Okay, sorry about that. I had to restart my computer. It crashed exactly whenever I was like, okay, let's get started. Let's get set up for the quiz. And it just froze up and I had to restart. And then it didn't just come right back. I had to go through some menus. So, thank you for bearing with me. I'm going to give it a second. Let me post the copy. First year Tuesday class. Okay, I posted the link in the Discord. Maybe that'll catch us a couple more people. So, we are almost done for the day. Can't wait to be completely done so I can do some other stuff besides this. Thank y'all for all participating. If you have any questions or comments about how today went, feel free to comment them in this video or leave them somewhere for me to see. Alright, we got a handful of people, so we're going to go ahead and get started. The force that pushes electrons through a circuit is called voltage. Let's see, did everybody finish? Yeah, everybody's finished. Cool. I'm going to take this down as soon as we finish and put up the full final quiz. Not final quiz, it's the overall quiz. That's the word I want to use. A multimeter must be placed in series to measure current. So, the nature of current is it stays the same throughout all the parts of a series circuit. So, to read that current, you have to be in series with the circuit. Opposite charges attract. Why does electrical current always flow through a circuit in a definite direction? So it's like air pressure or any type of pressure, water pressure. Things want to flow from an area of high pressure into an area of low pressure. And that's what electricity does. Whenever there's a buildup of electrons, that creates it to be more negative. And the electrons will flow from a more negative place into a less negative place. And that is why current is flowing in one direction in DC theory. In AC theory, it's still the same thing, just the spinning of the generator creates the back and forth. Ampacity is an invisible force that can produce heat. This is false. Electricity is the invisible force that creates all of those things. So it's a little bit of a trick question. Which formula will you likely use most often as an electrical worker? Ohm's law. You will use Ohm's law most often, and Kirchhoff's law is a close second. You won't actually use Kirchhoff's law, but the concepts of Kirchhoff's law will be used almost immediately. Electricity is the movement of electrons that have been energized by an external energy. The unit of current flow is the blank, which is represented by the alphabetical symbol I in Ohm's law. Amps, I stands for intensity. That's why it's I. It's the intensity of the current flow. The ampere is the unit for current flow. An electrical potential. So electrical potential is measured in voltage. And so if you ever hear electrical potential, it's voltage. If you ever hear flows, it's current. So current is the only thing that flows in a circuit. An electrical potential of 1 volt will cause 1 coulomb of current to do 1 joule of work. A coulomb is a number of electrons. It's a unreasonable number of electrons. And amp is actually the amount of time. No. An amp is a measurement of the number of coulombs that flow through a spot on a circuit in 1 second. Resistance is measured in ohms, which is represented in circuits by the Greek letter omega, which stands for omega. This is Ohm's law right here. You guys did good on it. I don't actually know how many questions we're going over. 23. Alright, let's go back to 12. Anytime one is measuring the resistance of a circuit, power should be removed from the circuit. This is what when you're actually doing it, like in real life. Anytime you are measuring the resistance in a circuit, you should remove the power from that circuit. Because it will damage the meter. Whenever there's current flow, the electron's inside of the battery. This is inside the battery. It flows from the positive side to the negative side, because outside of the battery it's flowing from the negative side back to the positive. Alright, 42 amps divided by 6 milliamps is 7,000. So, milliamps, this is just a division problem. It's nothing, it's not a real math, or it's not like a real circuit problem. With the resistance of a 120 volt electric lamp, so we're done. Oh. If the resistance of a 120 volt electric lamp can be measured at 80 ohms, how much current is the lamp drawing? So the formula here, and I don't have it up. Let's pull up Paint. The formula here is so this is what we call a magic circle. Bear with me on my drawing skills. So this magic circle, what you'll do is you'll cover up oh, it's supposed to be filled. Oh well. You'll cover up whatever you're doing. So if you're looking for I, you'll cover up the I, and it's E divided by R. If you're looking for R, you'll cover up the R, and it's E divided by I. If you're looking for E, you'll cover up the E, and it's R times I. So what's the question asking? We have 120 volts and 80 ohms. So 120 divided by 80. Can y'all see that? I doubt you can. So it's 1 120 divided by 80. That's going to give you 120 divided by 80. Boom. I've done too much today. It's going to give you whatever the answer is. 1.5. Sorry if I seemed distracted a second ago. Somebody was revving a dirt bike or something in front of my house. Same question, just different numbers. And again, same question, different numbers. Really wanted to drive that one home. Only blank can use power in an electrical circuit. Only resistance, and this statement holds true forever. Only resistance can use the power in an electrical circuit. A circuit is defined as a completed path for voltage to flow from a source of voltage through a load and back to the source. Voltage does not flow. Current flows. A complete circuit or path is often referred to as a closed circuit. Covered that one in a previous video. Covered this one in a previous video. When a circuit is open, voltage does not exist in the circuit. Voltage is just the potential for current. So even if it's open, there's still a difference of potential. Do it. 1 second. All right. Ohm's law states that it takes 1 amp to push 1 ohm. This is Ohm's law. It states that. Wow, 50-50? Somebody was ready to be done. All right. So that's it. I leaned a little bit too far out of frame. That's it. We're done. Congratulations. You made it through your first distance learning class. So, I'm going to put up the overall quiz. I don't know that I have one made yet. Let's see. Three. Yeah, I will have to merge the quizzes. Second. So we're on merged quizzes. 1, 2, and 3. Merge. Uh, 4 and 5, 6, 7. Merge. All right. The final quiz is up, and you are welcome to take it whenever you want. You do not have to do it today. We are done. You guys have a good couple weeks. These videos are going to stay up, so feel free to come back and rewatch them as you go.